back, everybody. This video we're going to be talking about some examples of applications of quadratic functions. First one here is the function graph approximates the height of an acorn in meters x seconds after it falls from a tree. After about how many seconds is the acorn 5 meters above the ground? So we're just going to look at the 5 meters here, go across, and it appears to happen right here. And if we follow that down about right here, a little bit less than 2 seconds, maybe 1.7 seconds. 1.7 seconds is when the acorn is exactly 5 meters above the ground. It starts at 20 meters, and then after 2 seconds it hits the ground. Alright, let's look at this one. The function y equals negative 16x squared plus v sub 0x models Julie's height in feet above trampoline x seconds after she jumps straight up. In the equation of the function, v sub 0 is her initial velocity in feet per seconds. Julie lands back on the trampoline 1 second after she jumps. What's the value of v sub 0? So let's get this function written out again. Negative 16x squared plus, some people call it v sub 0, meaning the initial velocity. Whenever you have a subscript of 0, it means the starting amount. So she's back on the trampoline 1 second. So think of the trampoline as ground zero. She's at 0 height, 0 feet above the trampoline. And that happens 1 second. So we can put in a 1 for x. X is the number of seconds. Alright, 1 squared is 1. 1 times negative 16 is negative 16. Negative 16 plus v of sub 0 equals 0. Add 16 to both sides. V sub 0 has to be 16. Her initial velocity, feet per second, 16 feet per second. We could just label it like that. Here's another one. We are talking about, let's see, Chris has a square piece of cardboard, cuts 5-inch by 5-inch squares out of each corner. She folds the sides up to make a box without a top. What equation can Carissa use to determine the volume of the box where x is the side length of the original piece of the cardboard? Express the equation in standard form. So it's a piece of cardboard, square. She's going to cut out little corners. And each of those corners is 5 by 5. And then basically what's left, the dotted lines here, just fold on the dotted line, and then you have this shape here, which I'll try to simulate the best I can, the 3D shape, kind of a box that's formed. So this is like the 3D shape after she folds up. Alright, and they don't tell us how long the box is, but we could just call that x from one side to the other. Keeping in mind we're folding off 5 corners, 5 by 5 corners of each one. Alright, so we're talking about the volume of the box. When you talk about volume, you're talking about length times width times height. And after folding this up, does it make sense that the height is 5? This little measurement right here. Now each side of the box is x minus 10. Let's think about that a minute. We should have these two 5s on either side. 5 and 5 make 10. And notice we have that on this side too. Alright, and that leaves us our volume. The expression is x minus 10 times 5. If we multiply out x minus 10 times itself, we're going to get x squared minus 20x plus 100. distribute the 5, and we have 5x squared minus 100x plus 500. And that is this expression can be used to find the volume of this box. We don't know what the volume is, they don't ask for it, they just want the expression. Alright. Next one, let's talk about this one. Allie is installing edge material around her yard. She has 400 feet of edge material just around the tree. 3 sides of her rectangular yard. The 4th side will be against a deck that does not need edging. What's the max area that can be enclosed by the edging? Alright, so rectangular area here. Let's try to get this figured out here. And this side is the deck. So no need to have edging there, just on those 3 sides. And we don't know what one is, so call this one X. That other one has to be X by virtue of a rectangle. And then we don't know this unknown side here, but we do know this. If you add them all together, it adds up to the 400 feet of edging. So we could say 2x plus question mark equals 400. So I want an expression for that question mark. I'm going to take away 2x from both sides. So I have 400 minus 2x. That's an expression in terms of x for that 3rd side. Now the question has to do with area. Area of a rectangle is length times width. In terms of x, instead of saying L, we'll say x, and the width we can call 400 minus 2x. Alright, and so what we want to do here now is find the vertex. If we were to graph this, and you certainly can on Desmos, it would be an upside down parabola. The vertex would tell us where the max is, the maximum area. Alright, to get this, let's get this in standard form if we're talking about vertex. We'll show how to do this algebraically. This is going to be 400x minus 2x squared. Putting this in standard form, 2x squared plus 400x. And standard form, technically a plus 0 here. A is negative 2, B is 400, and C is 0. Now, coordinates of a vertex, negative b over 2a. So in this problem, negative b would be negative 400. 2 times a would be 2 times negative 2. Negative 400 divided by negative 4, positive 100. Alright. And then to find what the actual area is, the maximum area, we're going to stick 100 back into the function. I'm looking back here, that's where I'm plugging it in. Alright, 2 times 100 is 200, 400 minus 200 is 200, and 100 times 200 is 20,000. So 20,000 square feet would be the max area of her yard that can be enclosed by the edging. Another problem similar to this, the farmer built a rectangular pen for his sheep. One wall will form one side of the pen. The farmer has 28 meters of fencing to form the other 3 sides. The farmer plans to build the pen so it has a maximum possible area. What's the dimensions of the farmer's sheep pen? Alright, very similar to what we just did. We have this wall here on one side. Maybe it's a barn. Who knows? He just only needs 3 sides of the fencing. Call one side X, the other side's X, unknown. We don't know what any of them are, but they all 3 add up. All 3 sides add up to the 28 meters of fencing. Question mark plus 2x equals 28. Question mark would equal 28 minus 2x. That's our expression here. Alright, area. Just like the previous problem, length times width. This problem, call length x with 28 minus 2x. We can distribute the x. And put this in standard form, negative 2x squared plus 28x. Again, if we were to graph it, vertex here would be a max. X coordinate of the vertex, negative b over 2a. Negative 28 over 2 times negative 2. 2 times negative 2 is negative 4. Negative 28 divided by negative 4 is a positive 7. So the dimension, we're just asking for the dimensions. We don't need the actual area. 7. 7 is one side. Put 7 over here to find the other dimension. 7 times 2 is 14. 28 minus 14 is 14. Alright, so here's our dimensions of our pens. 7 meters by 14 meters. And we could find the maximum area just simply by multiplying them out. Alright, so there's some examples of applications of quadratics. Appreciate you watching.